maybe the tool doesn't do it, or maybe I don't understand, probably the latter. So then I went to a different tool set and did what Darcy said, which is, since I'm doing all of these block printing exercises, I thought I would go with Aspire. And so I exported the bitmap, and then I just cut around the periphery of the bitmap with a vcarve bit and a couple of thou line. It goes, yeah. And it did a good job. So it's nice. Hi, Dave.
Interesting. It's interesting. So what it means, it kind of free, not that, well, it kind of frees you up from the slow boat from China. It's basically what it does.
Yeah. And okay, so all of this said, there are a couple of things that I've learned, and I'll pass my wisdom on. Rule 1, 3M makes this acrylic carpet tape. It's freaking awesome. Unfortunately, it's too awesome. I can't get it apart. So I glued the printed circuit board down to a piece of wood with the the double-sided tape.
Yes.
You think I could get that sucker off there? No. And when I did get it off, the tape was stuck to the back of the PC board, and I had to peel it, and it's acrylic, and it doesn't dissolve in the Gooby Gone, blah, blah, blah. It was a pain. Adrian says that Ray had a solution to this, which is you use painter's tape. You put painter's tape down, you put some on the back of the board and on the wood, and then you put a drop of cyanoacrylate between the two, and you glue the two pieces of tape together.
Oh, okay.
And then I was thinking to myself, well, I have double-sided tape, so I'm just going to, rather than CA glue, I'll just use the double-sided tape. So blue tape, double-sided tape, blue tape.
Yeah, that works too. Yeah.
Yeah. Anyway, the principle is, don't put that super good 3M tape on the bottom of anything. It sticks to everything. It even sticks to my tools, like cleaning it up. It's like, oh man, I got stuff all over the place. It's stuck to my hands. I got some on my elbow. It won't come off. It's like, So rule 1, don't do that. Slow boat to China. This has been awesome. Like, I've learned a ton about getting it done. Pretty easy to use. The downside is when you go with a real printed circuit board with a solder mask, that solder mask is a huge improvement. So you'll see right in the corner there, you see that? So anywhere the soldering iron accidentally touches the bare copper, you get blobs of solder all over the place. And it just kind of messy and a little harder to manage. So the solder resist mask keeps things from doing that. It's also particularly important when you get to this IC between the pads. It helps, like, there's a little ridge of solder resist, which keeps the bridge from wicking it. So I just use a little solder wick to clean it up, but it's just more work. On the other hand, this is about 2 minutes of CNC time, another 10 minutes to assemble it and cook it. And I have a USB to serial converter, which I didn't really need, but I wanted to try this. So
now that you raised the point about a solder mask, the bare PCB, does that have a mask on? Or sorry, how do you get a solder mask onto the PC, onto the copper?
You don't.
Oh.
Well, you buy it. You buy a board from China and get them to make it with a solder layer.
No. But when you do it yourself on the CNC, how do you do it?
You don't.
You don't
get it. You don't get it. That's the point.
You
don't have that feature. You're kind of in the... Now, that said, I did come across some guy who was using a photo imageable process, uses his photocopier to create it, and he actually puts down a layer of resist. So he does the PCB manufacture like I just showed you, and then he uses, he sprays the board with photoresist type plastic, which is UV curable, or I don't know which way it went. Whatever. It creates islands so that you could actually do that. To me, that started to be more like that chemical process, which I was really trying to avoid. And I never liked those solventy things a lot.
There's no tape that'll do it?
Yeah, maybe not. I don't know.
If you're cutting your board, just tape it up and then peel off the part that you want.
Well, I think you just have to realize that there are limitations to this process. If you want to, and just live with the limitations. China will deliver a board in 6 weeks or whatever for $2 plus another
Yeah, you
$4
can
to
actually
ship
get
it.
it faster than 6 weeks even.
Yeah, you can. You can.
PCB, my last order, I think, was under 2 weeks.
Yeah. So, and I often aggregate a bunch of boards together and
Yeah.
components and stuff. So when you do that, I just pay DHL, and yes, it costs you $25 or $30 to ship it, but
Well, I got mine
it's here
China
in,
Post under 2 weeks.
oh, wow, that's
Oh,
good.
that's pretty good.
Plus, you get two-sided, plated through holes, and
Absolutely.
Silk screened and all of
and
that.
an insertion guide. Yeah.
Yeah. So there are lots of advantage to the other. But when you're doing a quick prototype and you just want to, so I'm leaning towards, like, Darcy and I have been doing a little side project on upgrading his CNC mill to go from Mach to Gerbil. So he's refactoring the community machine. It'll be a Gerbil one. So he has a shield. We cut out the board, and I'm teaching him Eagle in the process. So as he learns Eagle, this gives us an opportunity to let people potentially try developing a schematic and building a board, but not spending any money or waiting, and actually having a quick turnaround and having some success. From there, you can always turn those into real boards that come later, especially if you're happy with them. So it's just a different opportunity to design. I also think Darcy had a really excellent point. The second board I did with Aspire, which is a different CAM tool. So I can go right out of a bitmap, which means the board shape could be whatever, cool Bezier curves. The traces can be round blobs or chains like a caterpillar or whatever, like you could go kind of crazy. So from an artistic point of view, to play around with badges or something like that, you can make some really interesting parts. So that's my weird thing for the day. Yeah. Because God knows we need weird things. But I mean, we had been talking about the PCB mills and the 3018s and stuff. So I thought, well, I better get ahead of this game, because as soon as you guys start getting your machines in, then the questions will come, well, how do I do this? And it's like, I don't know. So it's not as easy as, it's not impossible. It's not really all that hard. It's just when you start off, you don't know.
It's a secret recipe, that's why.
Yeah, well, no, it's not even that. It's just that there's a lot of recipes, and they have varying, the mileage varies, and depending on how precise you want to go, you can try and level the bed. And there's a whole bunch of techniques like probing your board to make sure that, like, how flat is it on the, you rather than flattening the bed, you just put the board down and then you probe the board at several points. And then there's a software process that will subtract the G code from the board flatness and
The slope.
Adaptive, well, not even slope, but even local depressions and dints and all that stuff, depending on how many points you take.
Yeah, I did see a demo of a specialized CNC for PCBs at one point, and they had a very big mapping process for mapping the nonlinear surface of the board. So
I was trying to take it, because I'm realizing, well, come on, guys, we're just starting out. I'm not going to make the finest detail. We're going to start with big things and go to smaller things. What I can say is the 0805 components, dead simple. 15 thou traces, dead simple. Standard, anything plated through holes, dead simple. The surface mount looks like it's pretty straightforward. Now, when we get down to the TQFPs with a whole lot of connections, we'll see how the lack of solder mask and stuff works out. That may be a big problem. But
Solderwick is your friend. Yeah.
Oh, and it's always been my friend. It's really expensive too now.
Oh, yeah.
$7 for a little roll of this stuff, and it's like,
well, it's copper.
I know, it's just copper braid, but it's still, no, it's my friend. What is Darcy doing? Oh, he's making a visor.
Well, I'm making some of those masks.
Yeah. Mm-hmm.
Oh.
Did you do the 3D print?
Yeah, they're all 3D printed. Just doing a box of 20 to get it out the door. Maybe tomorrow or something like that.
Who's that going to?
This one's going to a private individual, actually.
Okay.
20 units.
Nice.
Yeah.
Yeah.
Cool. Somebody gave me a donation. I forgot if it was 100 or 200 actually. So I'm just sending stuff out to whoever asked for it.
Yep. And
I pay for the postage with the donation. I forgot how much it was. It might be 200 actually. Yeah, someone.
Okay, Darcy, I see. If you looked in the paper, they're kind of drifting, like the face shield thing. They obviously
it's kind of out of fashion. I know.
Well, no, not so much out of fashion. Is that obviously the mask is going to be cheaper than something out of cloth is going to be cheaper. But the point is, they've raised the point is that the advantage of the face shield is first because you don't look like the masked bandit, and plus you don't people can see your face, they can see your mouth moving, because there's been an issue about people that lip read have trouble with masks.
Yeah. It does create a communication gap.
Yes.
Yeah. Like imagine working at a grocery store and having to listen to people mumble the whole time.
Exactly. The other thing is that apparently they're doing research to try to determine, how the general feeling I think right now, but how this thing literally changes every day, is that there's some view that it probably isn't quite as good as a mask, but how much, how much of a degradation is there? If there's not much of a degradation, and then you can, face shield may become more popular. So, and I must admit, mind you, now I don't find, as with most guys, to me, a successful shopping trip is a short shopping trip. Go in the store, get the stuff, get the hell out. So the thing is, wearing a face mask for something that doesn't last more than about 20 minutes is fine with me. Yeah. But
the downside of this is try buying filaments these days. The inexpensive ones are just plain gone, and anything left is really expensive.
Yeah, the industry that gains, it's the 3D printing industry.
Yeah. Interesting.
Yeah, I mean, it's not even like, you can find the stuff. If you go onto most of the websites that sell filament, 90% of their stock is just gone.
Is that right?
Yeah.
Is that right?
Yeah, you can get it, but you got to get a weird color, or you won't get the cheap one. You'll
be weird color, or the very expensive one that's like double the price, or it's just
I get it from 3D.
Darcy, I'm curious to do a quick demo of you. I'm curious, how do you hold the face mask to your head?
Well, you got the 3D printed part.
Yeah.
And then you get some of this rubber band stuff here. This is basically the stuff like on your undies.
Oh, yes.
Yep.
Yes.
So I took apart all my undies to make this.
Thank you. We'll keep that in mind.
Stay up anymore, but it's
thanks
all right.
Thanks for sharing, Darcy.
You want me to send you some masks? Anyway, this elastic band, which you can get in the dollar store, actually.
Yeah.
Some of it has buttonholes all along it.
Okay.
It's got buttons in the 3D print.
Ah, okay. Okay.
Oh, cool.
There's a guy on my Facebook who was making masks like that, but he was just using strips of ABS. So no 3D.
Yeah, I saw that too. Yeah. I think that would probably work fine. I didn't do it this way because, hey, Adrian.
Hi, guys.
Because I would have had to do like another hour of research to come up with, or even more to, get it actually working.
Yeah.
And this is
cool.
Established. So anyway.
You actually have a 3D printer, so that helps.
Yeah, I happen to have one yet.
So speaking of 3D printers,
pardon?
I'm going through a bit of an adventure with mine. So just got an upgraded controller board with the TMC 2809 drivers. But while I was looking at that, I discovered an issue with the software configuration of my current printer. It's configured to use dual Z drivers instead of just one with a splitter cable. And apparently I've been running with just one of them enabled for the last 7-8 months. And I've been having print issues and I couldn't figure out why.
You mean you have one motor that's freewheeling?
Yeah.
But at least, have you ever noticed when you turn one step or the other one turns automatically because they power each other? So
well, no, because they're on different drivers.
Yeah, this one's actually, it's not a splitter cable. You would actually see racking in your results.
It's very minor though, right?
Well, of course.
Because it is freewheeling, it's following it, but it's introducing vibration and my print quality was crap.
Interesting.
But yeah, it's fixed now, and I did a test cube on it last night, and it was just, oh my God, I can't believe I've been putting up with this for months.
Hey. Pat's got something pretty sexy there.
Pat definitely has something really sexy there.
Got the 2-bolt 3018.
Mm-hmm.
Oh.
What are we looking at?
That's a 3018. Oh, you have to open up the whole gallery to see everybody's thing there, Adrian. You know,
Yeah.
the little
Oh, Pat,
yeah.
are we talking about Pat's?
Pat's. Yeah.
Yeah.
Oh, okay, cool.
So the last Zoom call I was on was 3 weeks ago. So Dan O'Hara and I decided a couple of days later to buy a couple.
Mhm.
So that would have been the 27th or something, 28th of May. So this beast arrived around the 7th, and between Friday night and last night, I put it together.
Wow.
And did my first cut about 10 minutes before the call.
Oh, nice.
Works like a dream.
Yep.
I do have hints for anybody who's thinking of putting it together. You know, oops, take it apart, put it back together the right way. If anybody's interested, I've got those.
Yep.
But
You
the
guys got
delivery
them?
was quick. It was.
Dakota's got hers and Dave has his already. So that's 4 new machines.
Nice.
It
I
was
want to get
about
one, but I-
8 days to be delivered, and the
That's very good.
GST duty was $26 for 2, so $13 each.
Oh, wow. That's good.
I still want to get one, but I need a solder fume extractor system first.
The old priorities.
Yeah, so I
And-
don't inhale solder fumes all day.
You were
Well, I
totally
think
right,
the
Darcy.
short-term
The,
solution is outside, but
Was that Pat?
Darcy was right. The sawdust spray is minimal. It doesn't travel far.
No.
It just
Yeah.
And it's
sprays
nice
a
and
couple
light.
centimeters.
Yeah, and if you put some cardboard around it or something, like if you're doing something with a lot, like you're doing a lot of stuff. I made a cardboard box for mine, and I'm quite confident I could bring that anywhere and not bother anybody with dust.
Until you cut MDF.
What happens then?
I tell you, I did a job. It was with Richard. Do you remember, Doug?
Yeah. Oh, yeah.
And I'm still finding the friggin' dust
Dust.
everywhere.
I don't use MDF. The
horrible.
only problem is it has formaldehyde glue or whatever. So it's just kind of, it goes to a very fine particulate. It floats, but you can smell it, and it's an irritant, and it
Yeah.
gets everywhere. As
You know,
Adrian-
Yeah, there was an interesting little twist in all of that, because a little while after I'd done that major cutting for Richard, because it was an annulus with lots and lots of little holes for his LEDs.
Yeah.
So there was a lot of cutting, and there was tons of stuff in the air and everything. But I noticed that there was a run out on the bit. And I think I sent something around the group at the time. But what ended up happening is the dust, the fine dust, got inside the collet and around the ring, you know, the nut,
Yeah.
the base of the ring where the collet attaches.
Yeah.
And so every time you cranked it down, there was just a little bit of that dust.
Yeah.
And it was sufficient to cause the bit to be off-centered, which then, you know, caused a 2 millimeter bit to behave like a 5 millimeter bit.
I have seen this. Yeah, I've seen this. It's interesting. It almost forms like a little washer of dust, and it's just enough to. Yeah, it's surprising how sensitive that is.
So
After you cleaned it, did it come back?
yes, it was. The moment I cleaned it or worked out what it was and blew it out completely with compressed air, and then with just, you know, with a little fine knife or something, just scraped it away. Everything was fine, no problems with run out at all, none whatsoever.
Yeah.
But it was progressive. That was the strange part about it.
Well, I suspect once you get a little dust in there, and once it's slightly off, then it leaves gaps on the collet, which allow a little more dust in, and it gets a runaway on you. But yeah, it shows the precision that we're talking about. It's really quite amazing. Runaway, run out.
I mean, yeah, that's what I meant.
Yeah. So I have to introduce my other friend who's showing up today. That's a two-color block print.
Very nice, Doug. That's really cool.
That's Mr. Bunny. Yeah.
Yeah, surprise.
Well, I told Adrian that I was. That's my first version of a block print. I've done other ones with Darcy doing the toolpath for me, but that was my first version through the whole toolpath. So I was kind of pleased.
So we've met the ice bunny.
That guy's Aussie.
We've met the block print.
Yeah.
Now eat the stew.
Yeah.
There's a puppet bunny too.
Oh, I have. Yes, I can bring my puppet bunny if you're not careful. That's just to show you, Adrian, after our discussion, going back to making printed circuit boards with the etching technique through the mill. So.
Oh, show it up. Move it to the camera, Doug.
How much closer before it goes out of focus?
Keep going. Oh, very neat.
That's nice.
Very nice.
Yeah, so that's pretty fine. And,
well, actually, you've got the USB. Hold on, you've got a surface mount USB connector on there. So those are really very, very fine traces.
Yep, they are.
Very nice. What is it, a little CH340?
Yep, it's a CH340C. It's the one that doesn't need the crystal. And
crystal, right.
So it's just, I wanted a simple board that I could test and know whether or not it worked when I was done. Anyway, we did talk about that, and you said you'd made some boards in the past, so Pat's getting on there with his little machine. He's going to be turning out boards like crazy because I know he wants those things.
Yeah, so there's PCB way and now Pat's way.
Yes.
So maybe we should be sending our boards to Pat.
Oh, I love this idea. Said perhaps we'll send him some blank FR4 resin. Oh, there it is.
Your mic's off, Pat.
Oh, what is that?
What's that?
That's the same. That's the same thing that I have. Yeah, exactly.
Yeah, I buy these things for $1.30 US, and I buy them by the dozen.
Yes.
And I just hand them out to all my students and say, look, if you're stuck, just plug this in. And it gives you 5 volts and 3.3, so it'll feed stuff. It'll feed your ESP01.
Yeah.
And so I buy these by the bucket load. So I won't be making this particular board.
I wasn't proposing that anybody make that board. It was more, can we make boards of that class, and what class of boards can we make? And that was something that is always useful to just have an extra serial port floating around, and it just works. So
it was also, I don't know, we sent around a link. There was a link the other day about it was I think a Brit was talking about various techniques for surface mounting, and he was using FR4, but he was using a sharp knife.
Yes.
To to cut it, and I was amazed actually the sophistication of what he was doing, because it was very clean, very tidy, and an exceedingly rapid prototyping capability for surface mount in particular. Where you want to dedicate it to. My circuit boards are now taking anywhere from 2 to 3 months now. So, if you want to check something out properly, that was a really neat little technique I think he was using.
Yeah. Well, once you get over 24 pins, I think working it by hand is it's not fun.
It's not. No, absolutely. What he was doing was interesting. He was doing sort of like transistor circuits and things like that. So he would create square islands and grid them out. So by cutting grooves, they became disconnects in it. He's just creating islands that he can solder components between in various ways. We can now do this with the CNC machine, so you can create a bit of a CAD file, but not go too crazy, and there'll be a good balance between the two.
Right.
But it's interesting.
I suppose if one of us understood RF, it might be fun too.
Well, for me, that's
RF is just
black magic. Yeah, he said there's black magic smoke, and then there's black magic, and he said that RF. When I discovered RF was so weird, because there was this circuit and it had a transmission line down it, and it had a copper pipe to the grounded table at the end of it, and I'm going, that can't work. It's grounded because I'm Mr. DC, right? Well, in radio waves, that's not a ground. That's a nodal point where there is no anything, and it's still black magic to me. It's all just a big ass mystery. But cool. It's cool, but weird. Yeah,
Doug,
Greg.
if I'm allowed to reminisce for a minute, when I was very interested in microwaves. I actually took both a postgraduate course on microwaves, and there was a big discussion about wave guides, which we did those copper squares, copper pipes, and the professor was talking about them shorting out. Said, wait a minute, that's a solid piece of copper. How can you possibly have a spark across that? But he said, whoa, no, hold on a sec. He said the transformer, if you measure the DC resistance of a transformer turning, it's pretty low. Yeah. But you connect up AC to it and it doesn't draw nowhere near the amount of current that it would if it's DC. This is just exactly the same idea, just that much higher frequency.
Yeah. So on that microwave, we've seen people create Wi-Fi transmitters, like the tin can transmitters, to go further range. Like they make an antenna out of a tin can with a little Yagi in the middle and a tin can.
Oh, okay.
And one of the things that always struck me about that is such a nuisance, aluminum pins are easy, or a beer tin or something, but you can't solder to it. So there was a Hack613 thing where some guy had just sort of scratched off the aluminum, put some copper sulfate on it, and then electrolyzed it to form a copper flash on the aluminum. Then he soldered to that. And I'm going, oh, what a great simple solution. It was dead simple. It was like boom, 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 and it's done. So now you can solder to aluminum. So if you're ever wanting to solder to a piece of aluminum, have a look at Hack613. It was in the last week. It was actually quite a clever little piece. Dead simple. Yeah.
Well, it's something that I'm wondering whether this is in line with what we're discussing here.
Yeah.
This is a TTGO board which happens to have a Lowlin 915 megahertz transceiver on it.
You'll have to hold it a little higher.
Sorry, I beg your pardon. And then on the other side, it's got a little OLED.
Yeah.
But it's an ESP32 on the back, right?
Yep.
But have you noticed? Look at the aerial.
Yes, I know.
This is what we're seeing on some of the ESP32 boards.
Is that just a piece of bent metal?
Yeah, that's what it looks like, and and it's connected to the antenna.
Yeah. So it looks a lot like what Pat just showed on his board, but that was a piece of copper on the board,
exactly,
and it looks like they've just banged. Yes, well, a different shape of antenna, but they could have lifted it and done the same thing.
I think one of the things that strikes me about that is you have the same footprint, and the way you make that stamped feature changes the length of it.
Yeah. Yeah.
Yeah, you're probably right, because it's only it's soldered on three points that I can see. But if you look at Pat, if you put your little that's one of the old ESP32s, isn't it? 286s, right?
Yeah.
So on the ESP32 boards, that's often just a piece of real estate that nobody can use, right?
Yeah.
So, you think about, here's the ESP32 Mini, the D1 Mini, and this is an ESP32, but with the footprint just a little bit larger than an ESP8266. And this whole top area is real estate that's lost for the aerial. So I think that's what they're doing here. They're stamping it on there so that they're not taking up any additional real estate. Yeah, that's the same idea.
Yeah, so I have a QFN or one of those little quick chip connectors, and then a tiny little PCB. But I don't know if anybody's ever tried to make an antenna on a board like that. It's, again, really black magic. If you're not using 0402 or 0202 components to do the RF capacitors and resistors, it doesn't work. Like all the components at those frequencies have to be so freaking small that leave it to China or a machine or something. Just not worth doing.
Yeah.
Mm-hmm.
Yeah.
My attempted hack for the next week is somebody has written code for this old ESP01. They're what, $3 now, $2?
Yep.
He's written code to turn it into a true UART, transmit receive.
Yep.
And on the Wi-Fi side, it presents a web page and a telnet port. Now, the CNC machine that Darcy put us onto, the 3018, the Gerbil board is, what did you call it, a grasshopper?
Yeah.
Was that the code
Oh,
name?
woodpecker. Woodpecker.
So,
okay.
Woodpecker, sorry.
Yeah.
The woodpecker in the lower corner has an 8-pin socket for the external controller board, the thing where you can just plug an SD card in. Yep. And on that connector is 5 volts ground, transmit and receive. And what that connector does is it overrides the CH340 or the USB UART. So it just overrides it. So my plan is to hook one of these old beasts in via that connector and run the G code via Wi-Fi.
Cool.
Because on Linux, I use Linux all the time. I can tell Linux to make a fake UART and have it connect to the Wi-Fi telnet. And at the other end, I've got this thing picking up the telnet and pushing it into the Arduino that's in the CNC machine. Hopefully,
that's very cool.
Fingers crossed.
Yeah.
Because so there's no cuts or straps on the woodpecker. It's just plug into the existing socket.
I'll let
you know next week.
What's the board rate, Pat, that you're going to be running at?
115.2.
You can tell us to take any baud rate you want. 115.2, yeah.
Yeah.
So this thing, once it's programmed up, the little piece of code is called ESP link. Once it's coded up, this thing presents a web page. So I can use a web browser to set the UART rate and number of bits and start and stop and all that stuff. And then the transmit and receive pins on this thing can go right into the Gerbil Arduino and pump code into it.
So just a quick
question.
Well,
it's the 3 volt, 5 volt thing, but
when you do this on the Linux side, are you using SOCAT to move the serial to?
Yes.
Okay. Yeah. Thank you.
Yeah. Yeah. That's I've fallen in love with SOCAT this week.
Me too. I have found it to be quite a good for the rest of us out there who don't know what this is. This is. Go ahead.
It's Swiss Army knife.
Yeah.
It's a Swiss Army knife of communicating between things. You can have TCP on one side, you can have a fake UART on the other side, you can have a terminal on one side, you can have a file on the other side, and this just binds them together, and it makes a two-way link.
Yeah.
So normally, if you were copying a file, you'd have a source and a destination, but this thing sets up a two-way link, source and destination going that way, source and destination going that way, and it keeps it up. And so you could go from TCP to SSH, or you can go from a file to a UART, just about any Swiss Army knife combination you want.
And interestingly,
you can set the baud rates, you can tell it to.
But the applications that are running don't see it. That is, on Linux, if you run the Arduino IDE and it thinks it's talking to a UART, it could be actually talking to SOCAT, which looks like a UART to the Arduino. So you haven't changed Arduino. SOCAT sits in the middle saying, I'm a UART, talk to me. And then it sends telnet to the other end and shows up as serial on your target. And it's kind of like this transparent server.
Or to a file.
Slick. Yeah, or to a file, yeah. Anyway, remote access to machines is actually really, really cool. I'm looking forward to seeing how that works, because not plugging in saves you the risk of damaging your machine, because 24 volts and motors are not good for computers when you unplug them. Too many high voltage spikes. Yeah.
Okay. It needs extra wires anyway.
And wires, yeah.
Weren't you trying to do something kind of like this as well, Doug?
Yep. No, I was using SOCAT. That's why I was curious. I'm doing it a little differently because I have a little Linux computer on my boards, but same idea. Yeah. Yeah.
And it's, Doug, it would be just a matter of a wire to wire if it weren't for the 3 volt, 5 volt problem.
Yeah.
The grasshopper, the woodpecker is only giving me 5 volts, so I need to drop it down.
But
So I
interesting.
need 2 components. I need this
And a regulator.
and a regulator.
Well, it is interesting. Well, actually, you could do it with the resistors too. You could just do a divider, because the TX signal out of Oh, is that 3 volts?
No, sorry, for the power supply.
Oh, yeah,
This thing takes a
got it.
surge of 300.
Sure, got it.
300 milliamp startup. After that, it's pretty flat.
Yeah.
Well,
Well,
I was thinking of an LED, but no, got to be a regulator.
Yeah. Anyway, that's very cool. Oh, Darcy has his other toy. Dave, remember we were talking about water rockets the other day?
I will get.
And actually, I went on to a model rocket site for another reason earlier today, and they have a kit that will convert soda bottles into water rockets.
Ooh.
If anyone's interested, that's at allrockets.ca.
Can you, do you have a link to it? And I just throw it into the chat, and I'll grab it.
Hang on a sec. Where's the chat? There we go.
Thank you.
And they got the, I haven't looked at it in detail because I was just in there for talking to someone else about model rocketry today, and I was showing him that site. I just saw it on the banner at the top.
Thank you. It's now a bookmark.
I've actually
click done.
That's where I get a lot of my my parts from. So.
Okay, cool. Yeah. Sorry, Pat, I got distracted. I saw model rocket there, and gets me all.
Yeah, I'm kind of a moth to a flame with stuff like that.
Oh, yeah. Well, speaking of moth to a flame, Darcy has to do the mea culpa because he's got himself another telescope en route. I said, "Come on, Darcy, tell us about the telescope you bought."
Yeah, so I got this kind of entry-level telescope with a nice mount, and I've been playing with it. It's really fun, and I'm making carvings. Printmaking projects of the moon and stuff. And then I started researching online, and I was looking for the like an entry-level telescope, and I go into one of the Reddit groups on astronomy, and I started talking up the idea of it, and they showed a picture of the one I had and everything, and they're all like, well, and I got a bunch of people told me you should buy this, you should buy that, and it's some really nice ones, and some of the really nice inexpensive ones, the one I wanted, you can't buy it in Canada. It's US only. It's part of a fundraiser for Astronomers Without Borders, and you can't buy it.
But there was a border.
There's a border. You're damn right. Good point. What I wanted, I thought I could probably get it to Augsburg and all that stuff. Do that. And one of the other guys was saying, "Well, you should just save your pennies, kid, and get something decent." And I was all whiny, saying, "Yeah, but I want to be able to carry it in a knapsack, and I want all this other portable stuff." So the guy says there's this thing called ETX 80, which is the best one you can get that's still portable. Anyway, I was floating around, and I found it on Amazon, and I don't know, it was late at night, and I had nothing to do, so I bought it.
You were drunk. You were drunk. Come on, admit it.
But I might as well have been at the rate I was going.
But tell about the planetary drive and everything on it. It's cool.
It's all computer. So you just basically tell it what you want to look at, and it'll go look at the thing, and you just have to look in it. So it's got servos. It's completely automated on every front. Yeah. You can still wheel it around, but it's got full encoders all over the place on it.
How much did that set you back?
It was under 1,000.
That's not so bad.
Just under 1,000.
I thought it was going to be a lot worse than
online
that.
It says 300.
Oh no,
that's the American site, I'm sure.
Oh, it is, yes.
Yeah.
But there's more than one version, right? There's without the electronics and all this kind of stuff. But anyway, it come out. I have to go check it, but it was something like, I think it was like 700 or something all in. So it's still it's a portable, it's a knapsack observatory is what it is.
Well, you know what? We used to have, when we first bought this cottage, because we were out in the country, there was very, very little light pollution. And I bought a 6-inch reflector telescope. And, we could look at You know, we could look at the moon and some of the closer planets with absolutely amazing optics on it. But it was just a pig of a huge telescope. It's big and heavy on a massive tripod. And so Lise eventually encouraged me to get rid of it, and she wanted exactly what you're talking about. I've seen some systems which sit on a table, and they have all of the gearing to actually move them into the night sky and so on. And they've got a reference for north and so on. So, you know, so
like the Celestron, I think, was one of the early ones.
Right.
Yeah.
Right.
I'm kind of thinking of that because that was a small reflector, wasn't it?
Yeah. Yeah. Well,
I like the idea of the reflector because it just pulls in so much light. But but for Lise, the idea of having something portable that she could take outside and just sort of point up in the sky and allow her to kind of move around the celestial bodies.
Well, that one used to have I can't find it with a very quick search, but it used to be just a very quick link.
Take care.
Sorry, a very, like a 6-inch ball with a small tube over it, but it had a mount that was planetary and star following and all that stuff. But it was definitely something you could carry just in a backpack. And in fact, I think they had a sling so you could carry it over your shoulder.
I remember that they advertised the crap out of it in Scientific American, and I'm sure they did the majority of their business through people who were reading SciAm as a magazine, and
But yeah, this was like 20, 30 years ago. There.
Yeah, exactly.
For sure, I saw it. So yeah, just a quick glance on their site doesn't show it, but.
So you said you were looking at other rocket stuff. What does that mean?
No, I had a guy asking me just on Twitter how to get started in rocketry. So I was just grabbing some links of, Canadian Association of Rocketry and this store, because that's where I get a lot of my parts online, and links to clubs, because I know he's in Western Canada, but that's all I knew. So
okay, interesting.
Here it is. My order total was just shy of 700.
Yeah. Yeah, that's probably about the limit you'd want to do with a refractor, but I mean, it's certainly within the capability. And if you got good optics.
What I was not aware of, and Darcy pointed it out, but I haven't done any real telescope work. He said that the sky distorts the images, the actual air, because of thermals cause serious distortions, which I really hadn't considered.
Well, that's why telescopes
wasn't that the reason isn't that the reason for Hubble telescope?
Well, I suppose it removes the atmosphere. But I always thought the reason that originally, I've never really thought about it. Why put them at the top of a mountain? I just thought it was because it was real dark, no one around.
Well, there are several reasons. Atmospheric distortion is a big one. Lack of clouds and light pollution.
Right, because you're typically, like in the ones in Hawaii, they're all above the cloud layer typically.
Yeah. Same thing with the Atacama one in Chile.
Okay, yeah, I didn't know that, but
Haleakala, right at the top in Maui.
Yeah.
I've survived Haleakala.
I did too. I
have the T-shirt to prove it. I went to the top and I cycled down.
Oh, good for you.
Cycle down. Well, that's a good test of your brakes.
You're telling me, we were in a group and I just wanted to zoom down, and the leader of the group said, no, you get right to the friggin' back. So I watched somebody's ass the entire way down, and just held on to the brakes as hard as I could.
There you go. Does that look familiar, Adrian? That's the top of Haleakala. Looking down on the earth.
It was
way the hell up there.
That was a beautiful, beautiful early morning, 2 o'clock in the morning, and freezing cold.
Yeah. When the wind at the top of this thing is, you realize you're on a spinning globe because the winds are 70 clicks or more. It's like, there's a reason the bars are there, you hold on.
Yeah, but that's the main reason for the Hubble and the space telescopes, is you're free of atmospheric distortions.
Mm-hmm. And it goes even further if you want to go to James Webb, where you're getting rid of IR noise.
Right. Well, do you really get rid of IR noise?
Well, they're getting away from Earth and away from, you know, all the sources. And what they do is they have like a shield,
Yeah.
and then they have the hot side and the cold side.
Okay.
And then the hot side, you have all your power and, you know, all the electronics. And then the cold side has all the sensors.
Ah.
So I assume, Darcy, the Webb telescope is going to be much farther out than the Hubble.
Oh yeah, Hubble
No,
orbits
I think
the
it's
Earth.
the same altitude, isn't it?
No, Hubble orbits the Earth, but
Yes.
Webb is going to orbit L2.
Oh.
Yeah, I didn't realize
Oh.
that. Yeah.
Yeah.
That is out there.
Yes,
as a
When they
project,
launched
it's
James
really
Webb,
cool. Yeah.
When they launch James Webb, it's going to pass the moon on the first day after we watch it. It'll take
Wow.
off.
Wow.
Yeah. So
Well,
Adrian,
which Lagrange point is L2? Is that the one on this side of the moon or the far side?
It's on. It's on the other side of. It's away from the sun.
Yeah, but the L2 is where the gravity is equal.
The gravity is equal between the
that wouldn't
points.
always be away from the sun.
Well, yeah, L2 well, I mean, it's away from the Earth, from the, you know, like there's sun, Earth, then L2. And I'm supposing, I don't know the exact calculation, but I'm supposing that's where the gravity from the Earth and the sun are about the same.
No, that's L5. L2 is the gravity between the Earth and the moon.
okay.
Well, I mean, the gravity to the object.
Yeah, the gravity between the Earth and the
L2.
moon are the same, but not the sun. The sun is still different. The L5 is where the gravity is the same from Earth, moon, and sun. So L2, I believe, is this side of the moon. L3 is the far side of the moon.
Oh, yeah, one is between the two objects. So when they say it's like it's always with regard to one object orbiting another. You know. So L2 for Earth to Sun is farther, is like, yeah, it's Sun, Earth, and then L2.
Okay.
And oddly, I think it's fascinating that you can actually orbit L2. You probably can orbit all the Lagrange points. So it's like there's no object there, but you can actually naturally orbit around it, which I find kind of strange.
Yeah, so the L2 is actually the far side of the moon.
Yeah,
Far
so
side of the moon?
Yeah.
It's further out than the moon.
L4 and L5 are equal with the Earth and the sun, and then L3 is the opposite side of the sun from us.
Yeah, and then the 4 and 5 are like different parts of the orbit as we go around.
Cool.
Like ahead and behind us in the orbit.
So, Adrian,
Yes.
just before I leave, do you have some projects to show us?
Well, the only thing I am doing for, Sean hasn't been very well, so I've been concentrating on that. But I've been, you remember that I mentioned that I was working with this guy called Adrian, who often refers to himself as Adrian Molecule?
Yes.
He's the guy doing the the bioreactor to make reagents for COVID and other viruses and so on. And one of the things that he wanted help with was the creation of a rocking mechanism that where the reagent, the bag of reagent, the silicone bag of reagent kind of slops. It's got various ports on it for things like temperature control and liquids in and pH sensors and so on. But it rocks gently from side to side. It's got heating pads on the top and maybe some LEDs as well, because they're playing with photosensitive bacteria. And they wanted a cheap mechanism because this whole thing's got to be under $200 US. A cheap rotary mechanism that would allow this a movement of maybe up to plus or minus 15 degrees. So I came up with a very simple system, yes, using Duggalite or whatever we call this, HTPE. But I've made pins in the design. So the pin is actually in the HDPE. So I've removed all the material and kept a circular pin. and then it enables me to put bearings inside it and so on. So it's ends up being very small, very fast to make, but very cheap. There's the connector to the NEMA motor, and then the trigonometry allows this to move up and down about 14 degrees. So very cheap.
When you
very
say
simple.
pins, do you mean a bolt or do you mean a pin?
No, I mean a pin. So it's
Yeah.
I've removed all of the material on
Yeah.
the. I should have just taken it apart so you can see it. So there's a little pin, if you like, that's been machined. All the material has been removed from it.
Yep.
And the pin goes into the center of the bearing.
Yep.
It's the same diameter as the internal diameter of the bearing, and the outer part of the bearing is captured by the linkage, and then a self-tapping M3 goes into the pin and holds the assembly very firmly. But it's incredibly strong. I haven't been able to break this yet. And I have the same idea on this end here. So a pin on this part engages with the internal diameter of the bearing that is then housed in this bushing block.
So when you say pin, it's a plastic pin then?
It's a plastic pin.
Okay. Yes.
Yeah.
I get it.
6 millimeter diameter. Because the hole goes all the way through, rather than have all the stress on where the pin meets the rest of the plastic, I was also thinking of running the bolt all the way through and putting a nut there, just so it holds everything together.
Yeah.
Anyway, there we are. And then the bottom is just a coupler to a 5 millimeter D shaft.
And where did you get that beautiful little D shaft coupler? Because that's such an interesting little piece of metal too. It's not a traditional one that I'm used to.
I think I bought them. I've been using these a lot. Banggood, I think.
Okay.
It's a little. You can see it's a little shaft.
Yep. But it's got a nice big flange to work with.
A collar with a flange with M3 bolt holes in it.
Yep.
And that's just recessed below the surface. And so the other requirement was this whole thing take up very little room. So hence the geometry.
Cool.
But yes, those are beautiful. I'll send, if anybody's interested, I'll send around a link for those.
No, I am actually. I like those. Not that I'm going to order anything from China immediately, but when it comes off, I'm looking forward to getting some parts.
Yeah, and it has 2 set screws, as you can see. One for the flange and one for the opposite side.
Yeah. Nice.
And the other thing that you and I talked about, which I think might be of interest to the group, is that I've sent off for a couple of non-captive stepper motors. I don't know whether you guys are familiar with this, but it's basically a stepper motor that spins an Acme bolt or a regular bolt, and as a consequence, it allows a shaft to move linearly. So it does rotary to linear translation. But you can buy that. Yeah, go ahead.
Yeah, but it's like a hollow shaft stepper motor, and the hollow part is actually threaded and fires the bolt through it.
You have to constrain the shaft so it can't rotate, though.
Yes.
But you make a good point there, Darcy, because with one stepper, you have the opportunity for linear motion, but you also have the ability to control whether the shaft rotates in sympathy, in which case you get rotational movement, or whether you hold captive the.
That's a good idea.
And then it can move in and out. So when I get them, I'm going to play with them. But the idea was to make a very. You remember we were discussing the plasma cutter I have, and what I want to do is be able to move the plasma in an XY configuration. But there's very, very little weight on the end of plasma head, right? It's not carrying anything like a reel of welding wire or anything like this. It's very light. So rather than have a constrained rod and some sort of carriage that moves the head across the material, this idea of a linear motor pushing on one side a pair of shafts that come out and the head mean that it's sort of it's an unsupported gantry. And I was thinking I would use the linear motor of this non-captive stepper to push out or pull back the head, which contains the plasma cutter. And now I don't need, because I don't need support at the other end. The only restriction is how long the shafts, how long the shaft is.
This reminds me of those cranes. Yeah, the cranes, the sky high cranes. So when they're putting the load out, obviously the thing's going to dip down. So they're counter screw a weight the other direction. So I can imagine you've almost got this pillar supporting your head mechanism. Now it's light, but it's still, the further out you go, the more it's going to depress. So in order to keep it, you'll have to counterbalance it. But a mechanism like this could do that fairly easily, especially if the weight going out was bigger than the in, so you don't have to go out quite so far.
And again, because the head is so light, like there isn't a huge need for a counterweight. And I was thinking of using a pair of long bearings in the support rods to take the bulk of the weight, and then make the carriage, if you like, the stationary carriage that moves only in one dimension, to be quite beefy. But then I can drive out quite long rods with this stepper. That was the idea. So it's like a Core XY machine, right?
So that would solve the Maslow problem, where they lose the definition around the edges of the plywood, because that would be rigid, right? So that's cool.
Well, I think part of the Maslow problem of losing stuff on the edges is also it's the sine cosine problem, where the accuracy of the math starts as the small angle. It becomes really hard to do the math and actually make the steppers do little steps. So but I think that's part of, I mean, Darcy's drawbot thing, you did some of that stuff, and all drawbots that are like those Maslow CNC cutters, they all have that same geometry issue. As you get to the edge, you start doing the math on it, and you say, well, I want to move this motor such a small amount. The math rounding errors start to screw it up.
Oh, okay.
So I'm not sure though with this mechanism whether it would be an issue or not, because I don't think it is. I think it's more like a Cartesian machine where you're actually moving full linear distances. So the precision doesn't matter.
When you really think about it, we're taking rotational steps and converting them linearly to a one direction, a single direction. So it doesn't really matter where you are in that along that length, because the number of steps is for the incremental movement is exactly the same.
Yeah,
there's no trigonometry. This is pure Cartesian.
So it's so the response is linear, so you can actually work in the sweet spots of the model. So in that model, it's absolutely linear. As soon as you go to these trigonometric ones, they become non-linear. As you get closer to the edges, the accuracy starts to go to crap.
I was also thinking that it might be, its usefulness might be in that I'm floating above the material, obviously, but the material itself has to be supported on maybe a waterbed or like a metal table, or with
open grid,
open grid. And so I'm not investing in something that's already constrained the material size I can put under it.
Mm-hmm.
If I wanted to go bigger, I buy longer rods and maybe weld up a longer Acme thread or something, you know. So that's, anyway, I'm going to play with those. I've got some small ones on order, and if they work out as I anticipate, I'll get some bigger ones for the plasma table.
Exactly. What are they called again?
It's called non-captive stepper motor.
Yeah.
Thank you.
And if I, okay.
If you put that link in there that you sent me earlier, that it just gives a sense of what it is. But there's a whole bunch of them actually.
Yeah, there's a gazillion. Yeah,
but I'd totally forgotten about them. They tend to be a little more expensive than a traditional. Well, little. They're more expensive for the torque that they provide, but they're not expensive. So there you go. Whatever.
And Doug, and the other thing I thought the group might be interested in is the discussion we had with that little video clip of the guy doing holographs on chocolate.
Oh.
Which is,
yes,
it's really neat. The guy takes cheap dollar store holographic
diffraction grading,
and creates a working mold where he can melt chocolate onto it, and when he peels the chocolate away, it's actually got the diffraction grading and gives you a hologram on the surface of the chocolate. It really is quite astounding. I should send that video around too.
Ooh, Darcy just sent a pretty picture.
Yeah, that is a pretty picture.
I am getting distracted. I have to run right now, and I don't really want to do that, but sad but true. But you guys enjoy yourself.
Just quick aside there too,
Right,
Darcy. You were right about the L2.
Bye. See you, Lakota.
Okay.
P.S. Lakota, cute dog.
Oh, thank you.
Bye-bye. Talk to you more.
Bye.
Bye.
I've just put the
do we get the puppy picture on video there, Lakota?
On video? Sorry?
Yeah. Do you have the puppy with you?
Oh, no, we don't have the puppy just yet.
Oh, okay.
We'll have
Never mind then.
Preview.
Sorry?
That was a puppy preview.
Yeah.
And a puppy.
Mm-hmm. Yeah, we're getting him 2 weeks, in about 2 weeks. So
okay. You'll definitely have to show them on video when you get them.
Yes,
for sure. Yeah, we're picking him up on a Saturday, so I can show him the day after we pick him up. Hopefully, he'll stay still and.
How old will he be?
He'll be 8 weeks old.
Okay.
Go get him.
Okay.
But I might have to bring the camera to him so I don't scare him.
Well, I'm sure. Yes.
I've got a laptop problem too. I have to. Whenever I do a conference like this, I can't put the laptop on my lap because it's always.
I put those two links in the Zoom group chat. Darcy, do they get included, or should I just send them out on the link?
Well, if you put things in the chat window, what I've been doing is when the video arrives in the YouTube channel, I put all the content of the chat window as the description of the video.
Ah, okay, yeah. Cool. Well, I'm going to have to sign out.
Okay.
And nice talking with everybody.
See you later, Adrian.
Stay well. Cough into your arm.
Yes.
I cough at my cats.
Bye for now. Thanks, Darcy.
Bye.
Bye, guys.
Bye.
Yeah, I think I'm going to run too. I got to do some work on my 3D printer here. So I have a new controller card that needs to go into it.
Okay, man. Are those quiet stepper drivers?
Well, I got it fixed on the old software build, but yeah, the reason I got into that is because I was looking at building it up for the new controller. So this has got the TMC 2809 or whatever the number is, driver. So should be a lot quieter when it runs this time and a lot less vibration. So we'll see how it goes. I'll keep you posted.
Okay.
Later, guys.
Okay,
Have a
bye-bye.
good day.
Darcy, I do have a question for you, Darcy. Okay, now that they've got these links on the chat, and I see you can click on it, but I don't particularly want to click on it now. How do I get that? How do I get a copy of the chat?
Well, you got a couple choices. One choice is when you exit the session, I think it asks you if you want to keep a copy of the chat.
Oh, does it? Okay.
Either that or you've got it set as a default somewhere. So that's one vector. Another is we put this in YouTube. So I put the content of the chat in the YouTube.
Okay.
Description. Another idea is you could just copy paste out of the chat.
Yeah, I do that too. Notebook. Yeah.
Yeah, exactly.
Oh, okay.
You want to keep the links for later, then at least you got them.
Oh, I see. Okay.
I bet you as well. Doug was online, but he saved like $2 or something making that circuit board, which took hours. Well, for
yeah, but he admitted that it was mostly an exercise to
I
kind of
saved
see how he could do it.
$10 by rescuing this dollar store knife by making another handle for it. The cheap plastic blades fall off, so I just ground it. The knife cracked off, like the actual stainless steel actually severed at the handle. So it wasn't the handle that broke; it was the knife. So what I did was I just got out the Dremel and carved it back into something that would mount, drilled a hole in it, and then I made up this handle in Fusion and made it on the CNC, and then I put some broken end mills through it.
Oh.
Hole into the stainless steel, so it acts to make the handle stay together better, but it also anchors the blade into the handle. So this is just a piece of scrap wood and some broken end mills.
Nice.
It looks
it's not
good.
Money, is it?
Yeah.
You should have replaced the blade too while you were at it.
How about a new knife?
I'll replace the blade next. Yeah. Anyway, it was really fun to make it. Because
it looks good.
Thanks. So I was thinking like, oh, that damn knife's broken. So I thought, well, gee, I got a CNC machine here, and now with my new fusion my new world of fusion ability that I got thanks to a lot of people, but Ray in particular, and I thought, well, I thought, well, I'm pretty sure for the rest of the afternoon, I'm not going to get anything done except this. This is it's gonna bump everything else I felt like doing yesterday. But I'm glad I did it because every time you do something, you learn a few things. Here's another show and tell. It's not very well. Okay, it's Hack Your Family. So this here is 1, 2, 3 and me.
Oh, yeah, right.
So this is a DNA kit. So I'm going to give some DNA to this company, and then they're going to hook me up with more of my relatives in theory. That's the theory behind it. So I already did it in Ancestry, and it's really cool because I've been connected to all kinds of people, that I'm genetically attached to, and that's been kind of interesting. Like just yesterday or the day before, I was talking to a lady who grew up with my dad.
Oh wow!
So today I'm going to connect her to my dad. Is his cousin, my dad's cousin, who he's not been in touch with for probably many decades. I just happened to cross her because her DNA matches with mine. I think that's pretty amazing.
Yeah.
Telling all kinds of stories, and her stories match up with the stories I used to hear from my dad.
That's nice. Yeah, then you get the other side of the story.
There's an accuracy, the accuracy thing going on there, and
that turns into a debate. Yeah, I've sat through a few of those. No, that's not what exactly happened.
Yeah, that's pretty funny how memory is not so great.
No,
it
no.
Change over time, and so
Yes.
eyewitnesses in court can even be not that great.
Yeah.
It's considered the least reliable. Yeah.
Yeah, I remember this one time when I was a kid. I used to spill milk a lot. It was just this thing, I'd be at the table, I'd knock the milk over, you know. And then my dad get mad at me, and then the next time at the table, I'm like I'm so nervous about knocking the milk over, I knock the milk over. So like probably from the space of, I don't know, 7-year-old, like maybe 5 years old to 10 years old, I probably spilled the milk 40 times or something like that. Something that I used to always do is spill the milk. And I was visiting my parents, and I'm about, I don't know, must have been 30 or 40 years old. I'm visiting 35 years old or something. I'm visiting my parents, and we're at the table at breakfast, and my dad's got the milk in his hand. No one's thinking, and we're not even thinking of that joke of me spilling the milk, but it slips out of his hand. Okay, the milk slips from his hand. And you know that thing when you drop something and you go to grab it before he goes, before, you know, you go, oh, I try to get it.
Yeah.
Well, when he tried to grab it, the milk slapped down against the table with force, and then a whole bunch of milk shot out of the spout right in his face. His whole face was covered with milk. And behind him on the floor, on the ceiling and the walls and everything, there was milk. So that there was enough of a blast that the milk came out and went everywhere, and they literally had to repaint some of the wall behind them.
Oh no.
And you know, anyway, so I was out there when my brother got married again. Like I was out there another time when my brother got married, like I guess it's 4 years ago now. The story came up. My brother has one version, my mother has another version, my dad has another, and I have a version of what happened.
Oh boy.
There's not very much overlap between any of the stories. It's been told too many times, it's drifted.
Yep.
Everyone highlights it a little differently.
Yeah. So the reality is not captured. Only if there's a video does the reality get captured.
Oh, it's all real.
Yeah.
It's all real in a way, but when it comes to certain things like scientific things, we have to have tools so that we can, you know, and even in evidence, you know, video is good evidence for a lot of things. Even video can be confusing at times.
Yeah. I think that's.
Go ahead.
That's one of the issues about what they call the cops wearing these cameras in their vests. Even that's not a guarantee.
No, but
they know they're wearing them.
Yes, obviously.
Yeah, but it'll give us more information, and it's just another tool that will document what goes on. And I don't think it's perfect, like you say, but I think cameras are good. Videoing things is a good thing because later people want to argue about what happened, and well, if they want to have an argument, then they must also be interested in seeing not reality, but seeing of camera, which is higher potential of being objective.
Okay, I'm not going to agree with that.
No, I know
anyway.
You don't like cameras, but
no, well, just some things are just better left alone. So what about green screens? Can you have like a green, red, blue screen and have different things showing up on each screen color, or?
You mean in Zoom or like a?
No, just generally. Can you have like more than one color background? Like you can have
at the same time.
If you had if I had like the French flag behind me with 3 different colors, could I assign each one to a different?
In theory, yes.
Yeah, in theory, but does anyone do that?
Where's the software for that? Yeah, you'd have to either develop a software tool chain or a process to do that.
Right.
Like Zoom has a built-in thing that looks at the green screen and then it has 2 sources. Like one.
So other than theoretically, you've never heard of anyone actually doing it. Like you could,
not that's exactly that, but I'm sure that you could have a multiple green screen going.
You could color your coffee color one color, and like you have this doing.
You can have a video playing on your coffee cup.
Yeah.
And another video playing in your background.
Right.
Yeah. Now you could, well, you know, then there's other things to think about. Are do you want to do this in real time or do you want to post-process? You know, that's another question about how you want to approach something like that.
Right.
In real time, it might be more demanding to find a software tool chain that'll take care of that. Pretty sure if you looked at stuff like television. They have lots of equipment. Like it's like that whole green screen thing goes way back in television. And I wonder if that equipment, because what they do is they have like a green screen going, and then there's a weather or whatever, there's a map or something, but they also have other objects on the screen that they control. Now that's not that's overlaid, but it's not triggered by the green screen. But
Right.
there might be more than one green screen channel in there, you know, like in the hardware. I don't know.
I don't know either. Just thought I'd throw it out there.
Did you hear about with the Supreme Court doing a virtual setting of the court about the background of one of the judges?
Canadian
about
or
that?
American?
Because
No.
he had the same, he has just what you got right now, right? But his background was, of course, the Supreme Court chamber. But of course, every time he flailed his arms around, his shoulders disappeared.
What is this Canadian court?
Oh yeah, no, this is the Canadian Supreme Court.
Oh, okay.
It was just this day, just this week, that the point was that you know, needless to say, this is extremely innovative and also kind of controversial from a legal standpoint. And so to have something kind of funny like having somebody's shoulders disappear kind of caused some consternation.
Oh, I think right there, that's an argument against using it. You know?
Well, my reaction was, my God, Ken, I mean, surely he's probably in his office at home.
Right.
It'd be better if he just cleaned up his background a little bit at home and just stuck with that. Because I find don't take this personally, Ray, but I find kind of the background thing kind of off-putting because parts of you disappear.
Right. Has to do with the lighting.
Yeah, exactly.
Lighting and how much processing power and all those things in the computer. You know.
So on that note, I think I'll head out and we'll talk to you next week. Okay. Bye-bye, guys.
Okay.
Hi, Greg.
Bye-bye, Lakota.
I'll probably shut off the recording anyway, because we're probably wrapped up for our meetup.